Welcome students in your own channel M Institute the online classes achieve your aim. In this lecture of thermodynamics physics we discuss about Maxwell equation of thermodynamics physics. Then we know that thermodynamics have four coordinates P, V, S and T. P equals to pressure, V equals to volume and S equals to entropy and T equals to temperature. Then the equation which define the relation between thermodynamics coordinates. The equation which define relation between thermodynamics coordinates is called Maxwell equations. We know that thermodynamics have four functions, four energy functions. Four energy is what? U, F, G, H. U आपकी हो गई इंटरनल एनर्जी, F आपकी हो गई हेल्महोल्ट्ज एनर्जी, G हो गई गिब्स फ्री एनर्जी और H हो गई आपकी एंथैल्पी. Then we discuss about Maxwell equations by this four energy function. Then first equation Maxwell equation. Then see, we know that from first law of thermodynamics. What is the first law of thermodynamics? Equals to dq equals to du plus dw. Q is total energy, U is internal energy and W is work. Then dw equals to P d, which called pressure, volume, energy. Then put the value in equation first. dq equals to du plus p dv. Then from second law of thermodynamics, S equals to dq upon t, then dq equals to t ds. This is equation number second, and put the value in equation second. TdS is equals to du plus pdv. We know that U is the function of thermodynamics, energy function of thermodynamics. Then du equals to transfer कर देंगे TdS minus pdv. Then we put there two cases. First case, we have two coordinates there, S and V in differential form. Then first case is if V equals to constant, then the differential form of V is equal to 0. Put in equation third, du equals to, we define du equals to TdS, then du upon ds equals to T in volume constant. Then differentiation with respect to V in S equals to constant, then V, then upon then V, dV upon ds. यहाँ पे क्या constant होगा? V. And according to statement, there S equals to constant, and the second term is dt upon dv and S equals to constant. Equation number A. We denote that equation number A. Then second condition at case second. There we take V equals to constant and then there S equals to constant. Then S equals to constant, then the differential form S is 0. Put in equation third dV equals du equals to P minus P dV. Then we have du upon dV there as constant and there minus P and minus transferred and then P. Then next term differentiation with respect to S and there V equals to constant, then minus del upon del S del U upon du upon dV there S constant and upon statement there V equals to constant and the second dP upon ds del P upon del S there V equals to constant, transfer the minus sign, del S del U upon del V, S equals to constant all over V equals to constant del P upon del S there V equals to constant. Equation number B. Then we know that del square f upon del x del y is equals to del square f del y upon del x. Then from equations A and B, what we del t upon del b there as constant equals to minus del b upon del s there v constant. This is called first equation of Maxwell. Next, second Maxwell equation. Then we obtain second Maxwell equation by Helmholtz energy. Then from Helmholtz energy, what is Helmholtz energy? F equals to U minus Ht. From differential form, what is it? dF equals to du ds t. dF is equals to du. अगर अपन इसका डिफरेंशिएशन करते हैं then first term, second term differentiation, second term, first का difference. Equation number first from first law of thermodynamics. What is the first law of thermodynamics? TQ equals to du plus dw. dw equals to p dv. Then next ds dq equals to T ds. Put this is question second. Put in equation second. Then T ds is equals to du plus P dv. Then we put the value of du there. So du equals to TDS minus PD. We put value in equation first. df equals to TDS minus PdV minus SDT minus TDS. Then TDS cancel out. Then df is equals to minus PdV minus SDT. We have two thermodynamics coordinates in differentiation form. Then we apply two cases. Case first, V equals to constant, then the differential form of V is equal to 0. Then put value in equation third. Put value in equation third. Then we obtain df is equals to minus s dt. Okay, the next term df upon dt equals to minus s. There v equals to constant. Then differentiation with respect to v, and there t equals to constant. Then del f, del upon del b, del f upon del t, v equals to constant, and by statement t equals to constant, and del s upon del b आगे माइनस लगा देंगे. There t equals to constant. This is equation number 8. क्या C. Then case second is t equals to constant, and the differential form of t is equal to 0. Put value in equation. Put value in equation third. dt 0. Then this term is 0. df equals to minus p dv. Then 11 upon df upon dv is equals to minus t. There t equals to constant. Then differentiation with respect to t, and there v equals to constant. Then what we do, del f upon del b, del upon del t, and there t equals to constant, and according to statement all over v equals to constant. Then there in the second term del p upon del t all over v equals to constant. This is equation number D. Then we know that del square f upon del x, del y equals to del square f del y del x. Then from equation C and D, del s upon del e, t constant, and equal to del b upon del t, there v equals to constant. This is called second Maxwell equation. Next, Maxwell third equation. This equation we obtain by enthalpy, because enthalpy is energy function. Then from enthalpy, what is the enthalpy? Enthalpy is H equals to U plus PV in differential form. Differentiation form क्या होगी इसकी? What is the differential form? DH equals to DU plus D PV, then DU plus, this is the function of U dot V, then P dV plus V dP. This is equation number first. From first law of thermodynamics, then dq equals to du plus dw, dw equals to pdv, pressure, volume, energy. Put value, and dq equals to dd s, then put value dds is equals to du plus pdv. Equation number second. Then from equation second and first, dh is equals to tds plus vdp. This is equation number third. There we have two thermodynamics coordinates in differentiation form. Then we put two cases. We apply two cases. Case first is s equals to constant. Then the differentiation form of s is 0. Put value in equation third. dh is equals to vdp. Then dh upon dp. dh upon dp is equals to v, there s equals to constant. Then differentiation with respect to s, and v equals to constant. Sorry, there p equals to constant, not v. There p equals to constant. Then del h upon del p, and there s equals to constant, and del upon del s is all p equals to constant. p pressure क्या रहेगा? Constant. Then del p upon del s, p equals to constant. The next case second. What is the case second? There are second term p, and p equals to constant. then the differentiation form of P is also equals to 0. Then put value in equation third, and we obtain dH, because this term is 0 due to dP equals to 0, and we obtain dH equals to TdS. Then dH upon ds is equal to T, P equals to constant. Then differentiation with respect to P and S equals to constant. Then del H upon del S, P equals to constant, and del upon del P whole over S equals to constant. And the next term dt upon dP, there P equals to S equals to constant. This is the question E and this is F. Then we know that del square F upon del X upon del Y is equals to del square F upon del Y upon del X. Then from equation E and F, what we obtain? Del V upon del S, P equals to constant. P equals to constant, and equal to del T upon del P, S equals to constant. This is equation third of Maxwell. Next, Maxwell's fourth equation. This equation we obtain by Gibbs-free energy, because Gibbs-free energy is function of thermodynamics energy function. Then we know that from Gibbs free energy क्या होती है? Z बराबर U प्लस PV माइनस ST. In differentiation form, dz is equals to du dpv minus dst. After differentiation, pdv plus vdp minus sdt minus td as equation number first. From first law of thermodynamics, dq is equals to du plus dw, dw equals to pdv and dq equals to td as put value in equation second. dg is equals to TDS is equals to du plus PDV. Then from equation third and equation first, dg, there we put TDS plus VDP minus S dt minus TDS. TDS cancel out. Then dg equals to VDP minus SDT. There we have two thermodynamics coordinates in differentiation form, then we apply there two cases. Case first is P equals to constant. If P equals to constant, then the differentiation form of P is also 0. Then put in equation 4. Put in equation 4, we obtain dg equals to minus s dt. Then dg upon dt equals to minus s. There our p equals to constant. Then differential with respect to p, and there t equals to constant. Then next dg upon dt, del g upon del t, there p equals to constant, del upon del p, all over t constant. And next del s upon del p, there t equals to constant and minus again. Then this is equation G. This is equation Z. The next case second. What is the case second? Next second is t equals to constant. T equals to constant. Then dt, the differential form of t, is also 0. Put in equation 4. What is the equation 4? Then dz is equals to, due to dt equals to 0, this term may be 0, and vdp. Then dz upon dp equals to v, there t equals to constant. The next differentiation with respect to t, and p equals to constant. Input value del z upon del p, del upon del t, there t constant, and outside p constant. And then next term del v upon del t and p constant. This equation H. Then next we know that del square f upon del x del y equals to del square f upon del y del x. Then from G and H, del V upon del T P is equals to minus del S upon del P T. This is equation 4th of Maxwell. If you have problem to learn the Maxwell equations, we have short trick provide for you. Then write their coordinates, thermodynamics coordinates. Then make circle P2S and T2V. Then for first del P upon del S is equal to del T upon del P. Show their arrows. Then V constant and S constant and tap their negative sign. Question first starting. Then for second equation, we'll write down PV, TS, P2, T and S2, V. Del P upon del T is equal to del P, del T. Del S upon del P. Their D constant and their V constant. For third equation, we turn your reciprocal, the second equation, then del T upon del P, del V upon del S. Their P constant and their S constant. For fourth equation means first reciprocal of the first equation, del S upon del P and del V upon del T. Negative sign is there and P constant and T constant. There is short trick for learn the Maxwell equations, because this Maxwell equations is too important for us in thermodynamics solutions. Then for next lecture we upload 21 April. Please like, subscribe the channel and share also. This is for thermodynamics physics students or BSc students. Stay home, stay safe.